Okay, so welcome. Today we are going to be looking at atomic structure, and we're going to be starting off with some nice, easy things, I hope. But before we get started, please do pause this video and download your very own copy of this PDF so you can be making your own revision notes as we go through. Okay, so let's get started. So what is an element, compound, and mixture? So these definitions, you just need to know them. They're on the syllabus. You can't get artistic with them. You just need to know them for what they are. So our first one is an element. So an element, is a substance that cannot be further divided into simpler substances by chemical methods. And the really important part is this bit here. So all the atoms of an element contain the same number of protons. And this is really important. So hydrogen, you're going to be looking at hydrogen has one proton. If we have something with two protons, then it becomes helium, a different element entirely. So the key thing is that the number of protons dictates the element. And if you've got an element, it only contains the same number of protons. There we go. Okay, so now on to our next definition. So a compound. So a compound is a substance formed by the chemical combination of two or more elements in fixed proportion. And the elements do have to be different. If they're the same, then we've got a molecule, but we're looking at a compound. And again, we've got a key part of the definition, and it's the chemical combination of those elements. And in the fixed proportion. So this is like the ratio between the elements. So we can look at some examples. So magnesium oxide, this is in a fixed proportion of a 1:1 ratio. If we look at something else like magnesium chloride, this is in a 1:2 ratio. But both of these are examples of compounds. And now our final definition for now is a mixture. So a mixture is when you've got two or more substances that are mixed together, but they are not chemically combined. And because of this, they can be separated by physical means. So what's our important part in this definition is, they're not chemically combined. So what mixtures do we have? Well, we're surrounded by a mixture. We're surrounded by air, so that's filled with lots of different elements, but they're not chemically combined. It's pretty easy to separate air out to what makes it up. Another example could be like sand and salt. So that's two solids mixed together, pretty easy to separate. But even things like a solution. So if you've got like salty water, even though you think that might be chemically combined, it is not, because it can be quite easily separated by physical means. Okay, so there we go. Some lovely definitions. Make sure you remember them, because they will definitely come up at one way or another, especially our definition for an element. That is probably going to come up at some point in your final exams. Okay, so now on to atomic structure. So we've got AI to help us out. So this is what AI thinks an atom looks like, and this is what the GCSE textbook thinks an atom looks like. So let's compare the two to help us understand what is going on. So it's always good to have things that are maybe a little bit wrong, because it helps challenge our understanding, and then that hopefully cements the real idea in our head. So what we've got with both is we've got something in the middle. So this is the nucleus, and this is where the nucleons live. And the nucleons are the positive protons and the neutral neutrons. And then around the outside, taking up all of the space, we have, with both of them, the electrons. So the electrons live in shells, they do lots of whizzing around, and then they account for all of the volume of the atom. So this doesn't really show volume very well, but it's maybe a bit clearer with where the electrons are going. This is very colourful and all over the place, but we get the idea. Okay, so now let's look at the numbers for these in a bit more detail. So our protons and neutrons, the nucleons, they live in our nucleus. And protons are always +1, and they always have a mass of 1. Neutrons, no charge, and a mass of 1. So we can see our protons and neutrons, they have all of the mass. The mass of the electrons is 1/2000, or 1/1840. So that's basically nothing. But what the electrons do have, is they've got a negative charge. And in our neutral atom, all of the positives of the protons is cancelled out and balanced by all of the negatives of the electron. So those charges equal. So yeah, overall an atom is neutral. But in our next video, we're going to look at, when we have charges, and that's all okay. And the charges come from electrons moving around. So you need to know the electronic configuration for the first 20 elements. So where do the first 20, where do the electrons for the first 20 elements live? And we've got this diagram here to help us out. So what are these sort of things here? Well, these are shells. So we have 1, 2, 3, 4 rings of shells, and our electrons live in the shells. And you need to know, how many electrons can live in each shell. So we have our first shell here, and 2 electrons can live in the first shell. Then in the second shell, we can have up to 8 electrons. In the third shell, we can also have 8 electrons. And then in our final shell, for all you need to know for GCSE is, it can hold up to 2 electrons. So it's 2, 8, 8, 2. So when the shell is full, we move up to the next shell, as we're going to see now when we look at some examples. So our first example, we have hydrogen. So hydrogen has 1 positive proton, so therefore it has 1 negative electron. So where do those electrons live? Well, those electrons are going to live in the first shell. When I say electrons, it's just 1 electron. There we go. It's just in the first shell, and we are done. Nice and easy. So we don't need any of these shells because we only need to draw the shells that contain something. So your hydrogen with its 1 electron looks like this. So this is the simplest element. Now we have lithium. So lithium has 3 positive protons, so 3 negative electrons. So where are they going to live? They are going to live, again, in shells. So the first 2 in the first shell, that shell's full. So now our third electron has to go into the next shell. There we go. And again, we can get rid of the outer shells because they're not doing anything, as there's no electrons in there. So we have lithium. So lithium with its 3 electrons. And this is where we can start to look at the electronic structure in a little bit more detail. So we've got 1 electron in the outer shell, and all of the elements with 1 electron in the outer shell live in group 1. So we're going to do this in a future video looking at the periodic table. But so the outer shell, number of outer shell electrons tells you the group number. Not necessarily with hydrogen. Hydrogen's a bit of a loose cannon, lives on its own. But for all the other elements, the number of outer shell electrons tells you, what group it is in. Okay, so now let's look at our next example, which is argon. And argon has a very special electronic arrangement, as we will see. So it has 18 electrons. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, this shell is full. So our final 8 electrons have to go in this shell. So we've got a total of 18. And just like before, we can get rid of that shell there because there are no electrons in it. So why is argon so special? So argon has 8 electrons in its outer shell. So therefore, it's in group 8, and everything in group 8 is very, very stable. It's very stable and it's very unreactive, and that's because it has a full outer shell. So this is what all of the elements are trying to get. They are trying to get a full outer shell, and if they have a full outer shell, they don't really do very much. So argon is a very unreactive gas. But all of the elements, as we will see in our future videos, are trying to get this full outer shell electronic configuration. And how do they do it? They do it by bonding. Argon has already done it, so therefore it doesn't need to bond. Okay, on to our final example, and this is calcium. So this is the 20th element. So this is the last one that you need to know how to fill. And it's got 20 positive protons, so therefore it has 20 negative electrons. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, and then yeah, that shell's full, 19, 20. There we go. Okay, so what else do we need to know about the electronic configuration? So not only can we figure out what group the element is in based on the number of electrons in the outer shell. So calcium is in group 2 because it's got 2 electrons in the outer shell. We can also figure out where in the periodic table it is in terms of the period. So the number of shells that have electrons in tells you the period that that element is in. The more periods, the lower down that element is going to be. So calcium has got 1, 2, 3, 4 shells, so it's going to be in the 4th period. Okay, now finally we have isotopes. So isotopes are atoms of the same element that have the same proton number but a different nucleon number. They have a different number of neutrons in their nuclei. And yeah, some isotopes are radioactive, of course. So let's break this definition down a little bit. So yeah, because it's atoms of the same element, they have to have the same proton number. So each element has its own unique proton number. If you change the proton number, you change the element. So the only thing that you can change in the nucleus of the atom is the number of neutrons. So this is basically what an isotope is. It's the same element with a different number of neutrons. And our final part so some isotopes are radioactive. So what does that mean? This is more physics really more than chemistry, but what does it mean is that the number of neutrons kind of makes the nucleus stable, and if that number is too small or too big, then the nucleus is unstable, it's radioactive, so it undergoes decay, it changes what's going on in there in the hope of becoming stable. But that's physics, we don't need to worry about that. What we do need to worry about is how can we calculate the mass of an element using its isotopes. So this is what we've got going on over here. So if you were to look at your GCSE standard issue periodic table, you will see that all of the elements, their mass number, so that's the big number, the mass number is a whole number, apart from for chlorine, where it is 35.5. So why is it 35.5? Why does chlorine have a 0.5? And well, it's because of the isotopes. So you can't have half a neutron, but what you can have is you can have an average of the 2 isotopes. So most of chlorine is chlorine 35, but a little bit of chlorine, or a quarter of chlorine, is chlorine 37. It has a mass of 37. Do a bit of mass, you get the average of that, and it comes to 35.5. If you were to Google a periodic table and look at what's going on, you would be able to see that every element, all of the elements, most elements, their mass number is not a whole number, but for GCSE they're keeping it simple. They've rounded it up or rounded it down, but chlorine is the example that you need to know about. So how do we get 35.5? So what is going on? So chlorine has one isotope which has a mass of 35, and 75%, so 75% of all of the chlorine has a mass of 35. So you do 0.75 times 35, and then you are going to add that to chlorine 37. So 25% of chlorine has a mass of 37, so it's got 2 more neutrons. And when you put that into your calculator, you're getting your answer. 35.5. Happy days. Okay, so there we go. Thank you for watching. I hope you enjoyed. Please do tell all of your chemistry friends. The more people you tell, the more videos that get made. All right, catch you in the next one. Ciao.